Alright, welcome back everybody for part 2 of this two-part factoring tutorial. So what we got here is we're going to start with a trinomial. We got x squared plus 2x minus 24. Now, if you watch the first part, then you should know a couple things. This didn't actually come as 3 terms. This would have come from 4 terms. And those 4 terms that we would have gotten were from FOIL. And those 4 terms would be the first, the outer, the inner, and the last. Now, typically what happens with that FOIL is this guy winds up being the first, this guy winds up being the last, and then the guy right in the middle comes from some combination of the outer and the inner. So here's what I know at this point. I know that the first was x squared. I know that the outer and the inner combine together to turn into plus 2x, but I don't know what they individually were. The last I know would be negative 24. However, if you watch the previous part, then you know that the product of the first times the last should be the same as the product of the outer and the inner. So here's what we know. The product of the outer and the inner should be the same as the product of the first and the last. And I don't necessarily know what the outer and the inner are, but I know what the first and the last are. That's x squared and negative 24. So put it together, you got negative 24x squared. In addition, I know that the outer and the inner term are going to add up to plus 2x. So with those things in mind, and x's aside for the moment, this means that I am going to be looking for a pair of numbers that when I add them together, I get the o plus the I, that'll be positive 2, and when I multiply them, I get negative 24. Now, this was intended to be a relatively straightforward case. The two numbers that I'm looking for are 6 and negative 4. Now, a lot of you know that there's a shortcut associated with this. So then obviously the final answer is x plus 6 and x minus 4, and those are the two factors. Well, there's a little bit more to it than just that. So here's what I'm going to do. We're going to go through some gory detail together and talk about what's really happening. So some combination of the outer and the inner was positive 6x and minus 4x. So what I'm going to do is do exactly that. And I'm going to break it up, and I'm going to call this plus 6x and minus 4x minus 24. So this is my actual, what I would get when I FOIL those two factors together. Now, to go through the process of factoring backwards, FOILing backwards, is referred to as factoring. Now, the reason that I break it up into 4 terms is because I'm actually going to start looking for some greatest common factors. So in this case, when I group the first two together, x squared plus 6x, the greatest common factor that we can pull out is an x. What remains would still be an x plus 6. We can verify that by distributing the x back through. From the second group, I see that I have a greatest common factor of 4. The 4x and the 24 have a 4 in common, but anytime your group starts with a minus sign, I want you to use a negative greatest common factor. There is a method behind this madness, and I will share that. The method behind that madness is when I factor out that negative 4, negative 4x would become positive x, negative 24 would become plus 6. The reason that this is significant is because these two larger terms now have a factor in common, and that common factor is x plus 6. So, if I pull out that common factor of x plus 6, first term still has an x left over, second term has a minus 4 left over. Now, like I already said back in the lower right-hand corner, a lot of you probably know the shortcut, which is simply x plus 6 and x minus 4, and we're done. Well, that's great. That's exactly what we got using this technique. However, the shortcut is going to fail to work anytime we have a coefficient in front of our x squared, which is going to help motivate my next problem. Oh, snap. Things just escalated quickly. This time we're going to factor 15x squared minus 31x plus 14. Now, if you try the shortcut method, it's not going to work out on this one because of that extra 15 that's out front. So let's write down some things that we know. I know that 15x squared would have come from the f of FOIL. I know that 14 would have come from L. I know that this negative 31 would have come from some combination of the O and the I. So let's go to it. I know that O times I is going to be the same as the first times the last. First times the last in this case is equal to 15x squared times 14. So in this case that would be 210x squared. I also know that the combination of the O plus the I is going to be negative 31x based on how I labeled it back here. That should be the combination of the O and the I. Excuse me. So with that in mind, here's what we're going to do. X's aside, we're looking for two numbers that when I add them together, I get negative 31, and when I multiply them, I get 210. Now, you might not know these numbers off the top of your head. Well, I do because I, did this problem to warm up. If you don't necessarily know what they are, make yourself a little chart. And in that chart, we're going to write down pairs of numbers that when we multiply them together, we get 210. Now, there's a lot of pairs, so bear with me. We got 1 and 210. Check to see, does 2 go in? Well, it's an even number, so 2's got to go in. 2 goes in a total of 105 times. 2 plus 1 is 3, so it's divisible by 3. 3 will go in 70 times. Not divisible by 4, but it is divisible by 5. 5 will go in 42 times. We can do a 6 times 35. We can do 7 times 30. 8 doesn't work, 9 doesn't work, 10 does. 11 does not, 12 does not, 13 does not, but 14 does. Now as soon as you hit 14, we're at the end of our list, because the next number I would test would be 15, and I already know that 15 works, so we can stop right there. Excuse me. Some combination of these numbers is supposed to add up to negative 31 when I've got a positive 210. Now, in case you haven't seen it already, go ahead and put a little box around that guy right there. If we took negative 10 and negative 21, that would have a product of positive 210, but a sum of negative 30. So the two magic numbers I'm looking for up here, negative 10, negative 21. Now what that means for me is that I'm going to go back over here and I'm going to break up that middle term into those two terms, just like we did on the last problem. The problem with the shortcut is that the shortcut doesn't work in this situation where we have that lead coefficient. So as nice as the shortcut is, it doesn't always work. This method, this always works, and it's referred to as the AC method. We call it the AC method because calling it the FL method doesn't really work. A is typically the variable you see for your lead coefficient. C is what you typically see for your constant term. But really, the multiplication of the first times the last, mathematicians call that AC. So here we go. Once again, the reason I got 4 terms is so that I could factor by grouping. Now, first group doesn't start with a negative, so the greatest common factor that I'm going to pull out, 15 and 10 have a 5 in common. X squared and x have an x in common. If we pull those out, we've got a 3x minus 2 left over. Now, second group does start with a negative, so I am going to pull out a negative greatest common factor. 21 and 14 have a 7 in common. So that's what I'm going to pull out. As soon as I get to this step, I know I'm on the right track because my leftover factors match. Now I can pull that out as a greatest common factor. We'll wind up with a 3x minus 2 and a 5x minus 7 for a final answer. Great thing on these problems is you can always check your answer by foiling out the result that you got. Now, this is specific to trinomials, so what I'd like to do is go ahead and talk about a polynomial with 4 terms. Now, for a polynomial with 4 terms, I have some great news for you. We get to save a step. It's already separated out into this was first, this was outside, this is inside, and this is last. So, that's great news for us. Once again, let's group them appropriately. Doing the first 2 terms together, let's see, that's 2x cubed, 10x squared. I believe we can pull out 2 and 10 have a 2 in common. X cubed and x squared have an x squared in common. Excuse me. Factoring that out as a greatest common factor will leave us with x plus 5. Second group starts with a plus sign, so I'm going to make sure my greatest common factor is a positive. We got a 5ax, we got a 25a. They have a 5 in common with the 5 and the 25. They have an a in common as well. So I'm going to factor out the 5a. 5ax would become x, and 25a would become plus 5. So good news there. We do see that we have the same factor left over, so now we can factor out that greatest common factor, x plus 5, leaving us with 2x squared and a 5a. That is how this technique works. Now, this works specifically because if we had done that quick check with the first times the last and the outer times the inner, probably should have done this first. First times last would be 2x cubed times 25a. Outer times inner would be 10x squared times 5ax. In both of these cases, we wind up getting 50ax cubed. As long as those are the same number, we're in business. So I hope you guys find this helpful. Please feel free to go back, rewind. If you have questions, you know how to get a hold of me. Or leave them in the comments section. That'd be convenient too.